Hello everyone, this is our demonstration video for DTChecker, a tool for real-time signal monitoring and property specification in digital twin systems. In the context of digital twin engineering, verifying that a twin behaves correctly over time remains a challenge, especially when it comes to specifying and checking complex temporal properties. This is mainly because temporal logic is difficult to write. Its syntax is not intuitive. For example, a seemingly simple property like between Q and R, P should always hold, already requires a non-trivial formula to express. To solve this problem, we used Xtext to create a domain-specific language for writing specifications, based on property specification patterns. The snippet of the grammar's definition shows how the response pattern is modeled. Here's a simplified view of the meta-model of our DSL. Specifications are defined by a combination of scope and pattern. The scopes and patterns refer to expressions, which are comparative Boolean expressions between two signals or between a signal and a number. We use an extend template-based code generator to transform specifications into temporal logic formulas. The generator also produces Python code that connects to real-time data streams. Specifications are evaluated on this incoming data, allowing us to determine whether the system is satisfying the expected behavior at runtime. The tool is a monitoring service that integrates into digital twin architectures that use RabbitMQ as message broker. Domain experts write specifications in a web-based text editor. Once this is finalized, the parsed model of the specifications is sent to a template-based code generator, which creates the script that connects to RabbitMQ and evaluates formulas. This script is then executed and starts listening to messages from RabbitMQ. Every time a signal is published, all the specifications that depend on it are evaluated. The output of an evaluation is a robustness score, which is a number that describes how close the requirement is to failing if it's positive, or how severe the failure is if it's negative. Robustness scores are sent back to the front-end via a server-sent events channel to update the graphs. For the demonstration, we integrate DTChecker with a free open-source digital twin of an incubator. An incubator is a sealed box used to maintain a controlled environment. It is commonly used for hatching eggs or supporting biological experiments that require precise thermal regulation. Inside the box there is a heater to control the temperature, a fan to ensure even heat distribution within the box, and temperature sensors. In the demonstration, we want to monitor 4 properties. The temperature inside the box should never exceed 32 degrees Celsius. If the temperature gets close to 32 degrees, the heater should turn off shortly after. This is to prevent overheating. Also, the temperature should never drop below 30 degrees, and the fan should be activated whenever the heater is on. So this is the web interface of DTChecker. On the left we have the DSL editor, and on the right is where the graphs will be generated. We will start by defining 2 signals, one for the temperature inside the box and another for the heater state, whether it's on or off. To do so, we only need to know the name of the RabbitMQ queues of these signals. We will use global scope and universality pattern to specify that temperature should always be below 32 degrees, and response pattern to specify that if temperature exceeds 31.8 degrees, the heater must turn off within 3 seconds. Now we click on the Monitor button and graphs start appearing as the specifications are evaluated every time a signal value is published. Each graph shows the evolution of robustness scores over time. For additional feedback, there are also graphs for signal values. We know a requirement is satisfied when the robustness is positive, otherwise the requirement is violated. These are the generated graphs after specifying all 4 properties. Graphs in red indicate that the specification is failing, while blue indicates the requirement is satisfied. We can use a tab menu to focus the view on specific requirements.